Greetings. Welcome to Algebra. In this chapter, we're going to be laying the groundwork for our future discussions, and in doing that, we're going to be basically talking about three ideas. An algebraic system is composed of three elements, three primary elements. One is a set of numbers, and we're going to establish the set of numbers early on in our discussion. And the next element after the set of numbers is operations like adding, subtracting, multiplying, dividing, and there are many other operations as well. But so we have the set of numbers, the operations, and then we have properties. And those properties are those rules that allow us to perform certain operations in a certain way with that set of numbers is what algebra is composed of. Well, let's start with the set of numbers. The set called natural numbers is the set of numbers 1, 2, 3, 4, and so on. Now, the ... means and so on in the pattern that has been established. Now, the set idea is that a set is just a collection of items, and here we have a collection of numbers. And this way of writing that set is called the roster method. And the braces here say that everything in the braces will describe what's in this set. And we are actually describing the set by listing the items in the set. Another set of numbers that will be referred to from time to time is a set of whole numbers. And the set of whole numbers and natural numbers are very similar to one another. When we take the set of natural numbers and add this element called 0, then we get the set of whole numbers. So whole numbers would be this set. Integers would be a set that can kind of informally be described as positive and negative whole numbers. Now, 0 is neither positive nor negative, so that doesn't exactly apply, but it's fundamentally that idea. So integers would be ... -2, -1, 0, 1, 2, and so on. You see, so we have and so on in both directions here, in both this positive direction and this negative direction. Now, a lot of times integers and other numbers are illustrated on a number line. The number line is composed of a position for something like 0, and then positions for other numbers. And typically, positive numbers lie to the right, negative numbers to the left when we're talking about a number line. And when we locate a position on the number line, like here's the location of 1, we're actually graphing the number 1. So the graph is just the dot on the number line that's associated with that number. Okay, here's another number line. It goes -4 all the way to 4 over here, and the arrows indicate that each end extends infinitely far. Because we have a number line written here, we can actually place numbers in order. We can create an order relationship. And that order relationship, when we describe it in terms of less than and greater than. Now, if you just kind of look at the number line, especially at the positive side, you notice that the larger numbers are to the right of smaller numbers. And that's just fundamentally our idea about order on the number line. That a number that lies to the right of another is greater than that other number. So, and a number that lies to the left would be less than another number. So, we could say then that -1 is less than 3. Now notice this is the symbol for is less than. And here's the symbol for is greater than. So let's see, -1 is less than 3 because -1 lies to the left of 3 on the number line. 0 is less than 2 because 0 lies to the left of 2 on the number line. Now, if there's any challenge in determining order relationships on the number line, it's between any two numbers that are both negative, because it's a little bit counterintuitive. When we see, for example, -3 and -1, now from the number line, you see that -3 lies to the left of -1, so we know that -3 is less than -1. But when we just look at digits here, 3 and 1, it sort of goes against the grain a little bit because we know that 3 is greater than 1, yet -3 is less than -1. All right, and 2 is greater than -3 because 2 lies to the right of -3. And indeed, any positive number is going to be greater than any negative number. So when we see positive numbers and negative numbers in this order relationship, we can very quickly determine which one is larger than the other. And let's see, 3 is greater than 1. Negative 1 is greater than negative 3. Here's that situation with two negative numbers that we have to be careful about. Think about where the numbers lie on the number line. You see, negative 1 lies to the right of negative 3, and we can see that up here. Negative 1 lies to the right of negative 3, so negative 1 is greater than negative 3. All right, so we write greater than. Let's put the proper symbol into these pairs of numbers. What about for negative 8 and negative 2? Well, negative 8 lies to the left of negative 2 on the number line, so negative 8 is less than negative 2. Here we have a positive number and a negative number, and it's always true that a positive number is larger than or is greater than a negative number. So 5 is greater than negative 6. Now here are two negative numbers, negative 36, negative 49. Which one lies further to the left, you see, is kind of the way to think about this. Negative 49 lies further to the left of negative 36. So negative 49 would be the smaller number. This would be the larger number. So negative 36 is greater than negative 49. And here we have two numbers. One's positive, one's negative. The positive number is always greater than the negative number. Now, there's a tendency to forget what this says and what that says. There's a tendency sometimes to think, well, which symbol means greater than and which one means less than. And if you forget, you can always remember, kind of like this, that the little arrow seems to always point toward the smaller number. And so if you forget the meaning of this, then you would do something like this. Write down two numbers that you know the relative size of, like 1 and 5. And then make the arrow point toward the smaller of the two. Let's make the arrow point toward the smaller, and then we'll read it as we understand it. We understand that 1 is less than 5. Oh, this means is less than, you see. Now, if we had written the two numbers this way, it would be fine, because the little arrow tends to point toward the smaller number. Let's make the arrow point toward the smaller number and read it as we understand it. We understand that 5 is greater than 1. Oh, this symbol means is greater than, you see. So if you forget, just use this little trick. Now, it is possible to describe relationships among numbers where we have either less than or greater than, but or equal to. And a symbol that has this little mark on it means or equal to. So this says negative 1 is less than or equal to 3. Now certainly we know that negative 1 is less than 3, is definitely less than 3. But when we start to put letters into these relationships, the or equal to situation may come into play. Okay, suppose we want to write the set of positive integers less than 5. The set, if we're going to write a set now, we're going to use this roster method, this idea of putting the set symbols here, and we'll list the items that are within that set. So we want the positive integers less than 5. Now strictly less than 5, that means 4, 3, 2, and 1. We don't list 0 because 0 is neither positive nor negative. The first positive number to the right of 0 would be 1. So this would be the numbers 1, 2, 3, and 4. So this is the set of positive integers less than 5. How about the set of negative integers greater than or equal to negative 4? Greater than or equal to negative 4. Now, to help with this process, sometimes if there's any confusion whatsoever, then either imagine or draw a number line. So we want the set of negative integers, we're over here now, greater than or equal to negative 4. Greater than or equal to negative 4. That would include negative 4, negative 3, negative 2, and negative 1. All of these are negative, and they're greater than or equal to negative 4. So the set containing negative 4, negative 3, negative 2, and negative 1. In this one, we're given that A is the set containing negative 27, negative 14, 14, and 27. Which elements of set F, oh, I should have made this an A. Let me make this an A. which elements of set A are greater than negative 15? Greater than negative 15. Now think in terms of greater than on the number line means to the right of. So to the right of negative 15, which of these numbers would fall? Well, it turns out that certainly the positive numbers are greater than negative 15, but also negative 14 is greater than negative 15 because it lies to the right of negative 15 on the number line. So this would be the set consisting of negative 14, 14, and 27. Another idea associated with the number line is the idea of opposite. And on the number line, we think of the zero kind of in the middle of the whole situation. And when we think of opposite, we just go the same distance on the other side of zero. For example, the opposite of 2 would be negative 2. You see, same distance, but on the other side of 0. Now, the opposite of negative 2 is 2, because given this distance, you see, here's the distance from 0, the same distance on the other side, you see, would put us at 2. So it's the same distance on the other side. The opposite of negative 2 is 2. The opposite of 2 is negative 2. Now, this little symbol is the symbol that means the opposite of. Now, what are we going to call this symbol? We can call it the negative of. Usually it's called the negative of, or negative. But minus isn't too bad either. And we'll have a lot more to say about the relationship between and the difference between the notion of minus and the notion of negative. I kind of like to think of them as interchangeable parts, and we'll see why in a little bit. So let's see. This means the opposite of. We read it as negative, but it means the opposite of. Okay, the opposite of negative, the opposite of 2. The opposite of 2. You see, or negative 2 means, let's see, the opposite of 2, that would be negative 2. You see, just without the parenthesis. And this is the opposite of negative 2. All right? Or the opposite of 2. Let's interpret it both ways using the number line. The opposite of negative 2. Okay, here's negative 2. The opposite of negative 2 would be 2. Okay, so this is 2. Now, let's read it the other way. The opposite of the opposite of 2. What's the opposite of 2? Negative 2. Okay. And what's the opposite of the opposite of 2? That is the opposite of negative 2. Oh, it's 2, so it would be 2. So either way we look at it, we're going to come out okay. Here's the opposite of negative 30. I think this is the easy way to do it. The opposite of negative 30 would be positive 30, or simply 30. Incidentally, when we don't write a sign in front of a number, it's understood to be positive. Here's one that's rather interesting. We're going to let letters stand for numbers a lot of times, and we don't know whether the letter to begin with is positive or negative. But let's take on this problem. If A is positive, then what does this mean? Well, the opposite of A would be negative. All right. Now, let's change things around a little bit. If A is positive, then this symbol, the opposite of that A, would be negative. What if I make this negative? What if I ask if A is negative? Okay, if this number is negative, then that number, which is the opposite of that negative number, would have to be positive. And it looks wrong to represent a positive number like this because of that symbol. Because that symbol says negative or minus. And we tend to think that every time we see that, we are representing a negative value. But if A itself is negative, then this is the opposite of a negative number, which makes it positive. So it's possible to use this symbol with a variable, with a letter, and still be representing a positive number. Kind of an important idea. The notion of absolute value, and this is, absolute value is, we can think of it as an operation. The operation of absolute value has to do with distance from 0 on the number line. And all it is saying is this. Let's take the definition of absolute value as distance from 0 on the number line. And so the absolute value of 5, since 5 lies 5 units from 0, the absolute value of 5 is 5. The absolute value of negative 5 is also 5, because this number is also 5 units from 0 on the number line. It's just in the opposite direction, you see, from that number. But the absolute value of negative 5 is 5. So the absolute value of some number will always be positive, because we take distances to be positive regardless of the direction where we're going. Generally, unless we say it's a directed distance, which means that we would associate a positiveness or a negativeness to it. But for right now, for absolute value, distance is always positive. So absolute values of numbers are always positive. Now, consider these situations. The absolute value of 10. 10 is 10 units from 0, so this is 10. The absolute value of negative 12, easy, 12. 12 units from 0. Now, what about the opposite of the absolute value of 5? You see, this part of the problem is 5, but this is the opposite of 5, which would be negative 5. In this one, the absolute value of 4 is 4, because 4 is 4 units from 0 on the number line. The absolute value of negative 4 is also 4, because negative 4 is 4 units from 0 on the number line. And this is the opposite of the absolute value of negative 4. But the absolute value of negative 4 we know to be, this is 4. So this is the opposite of 4, or negative 4. We're going to talk now about adding and subtracting integers. This is a process that can be taught and learned in a lot of different ways that are compatible with one another. And I'm going to show you the method that my students use, and it's a method that I've come up with over the years where my students make the fewest number of mistakes. It's a relatively easy situation, but we've got to, instead of thinking about adding and subtracting, we're just thinking of collecting. And when I say collect, I mean just bring numbers together. Now, here's the way the situation works. If we're collecting signed numbers, now notice I'm not even saying integers here. I'm saying signed numbers, numbers that have a sign associated with them. We're collecting them, we're bringing them together. And we don't think of positive and negative so much, and adding and subtracting so much. We're just bringing two numbers together and we're looking at sign patterns. Okay, so when the numbers have like signs, when the signs are the same, either both positive or both negative, then we add the digits. You see, we disassociate ourselves from the sign for a moment, and we add the digits, and then we attach that common sign. Now, I'll show you plenty of examples in just a few minutes, but that's all there is to it. If both signs are positive or both signs are negative, then add the digits and attach the common sign. Now, when we have unlike signs, we subtract digits. Now, when I say subtract digits, we disassociate ourselves from the signs. Just look at the digits and take the small digit from the large digit. That's all. So we subtract in the way that we intuitively know how to do. And then we attach the sign of the larger digit. All right, let's look at some examples. Here we have 4 plus 3. Now, intuitively, 4 and 3 is 7. You see, and that's what we're going to get as the result. But if we're thinking of this in terms of signed numbers, we have an understood positive 4, and this is a positive 3, or we can think we're adding a positive 3. So the signs are the same, and we add 4 and 3 to get 7, and we attach the common sign plus. Now, a lot of times we don't write plus signs in an answer like this. We would just write 7, and it's understood to be positive 7. But I'm just putting the plus in here for emphasis. Here we have 4 minus 3, and we understand intuitively that since the first grade, 4 minus 3 has been 1, and it's going to be 1 here as well. But we can think in terms of what we were talking about over here, that this is an understood plus before the 4. I can write it for emphasis. We have different signs, so we disassociate ourselves from the signs for a moment. We take the small digit from the large one. We take 3 from 4 to get 1. And we take 3 from 4 to get 1, and we attach the sign of the larger one, and it's plus or positive. So we're going to get 1. I'm not going to write it this time. Now, another way to think about this is to do this. We can say, gee, subtracting 3 is the same thing as adding the opposite of 3. So this could be shown as adding the opposite of 3 is negative 3. So this could be 4 plus negative 3. Now, in the day-to-day affairs of algebra, we perform these operations many, many times. And we want to try to write as few symbols as we can possibly write, I think. And rather than go from a step like this to a step that looks like this, I would rather we stay in this kind of notation and understand that this says subtract 3, but it means the same thing as adding the opposite of 3. Now here's where the lines between subtract and negative, you see minus and negative, become somewhat blurred, because after all we can sort of change between those two and they pretty much mean the same thing. So in either event we're going to take 3 from 4 and we're going to end up with positive 1, you see. So I kind of prefer this method to this method, and in fact when I see this I often want to go to that in order to just make it a little simpler to see through. But this is going to be kind of up to you and up to your teacher as to how you want to look at it and think about it. Here's another one. This is minus 5 or negative 5, minus 3 or negative 5 collected with negative 3. We can think of it this way. We can emphasize the idea that this minus 3 means the same thing as negative 3 by writing negative 5 plus negative 3. You see, subtraction is the same as adding the opposite. And so we could write it like this, and it would mean the same thing. But just looking at digits like this and seeing the common sign, you see the same sign, add those digits, and attach that common sign. And that's really all there is to it. Here, same idea. We have the same sign, so we add digits. 2 with 10 is 12, and attach that common sign. So it's a very quick process like this, and we don't have to write a step that looks like that. Let's look at a few more. We have negative 9, or minus 9, plus 4. And here, the signs are different, so take the small digit from the large digit. See, disassociate ourselves from the signs for a moment. Just ignore the signs and take 4 from 9, we get 5. Now, attach the sign associated with the larger of the two digits. The sign in front of the 9, oh, negative, so it's negative 5. Now, all of these collection problems can be seen by using a number line. We could take a number line and start at 0, and then go on the number line, starting at 0, go to negative 9. So we would go to the left over to negative 9. And then plus 4 means go in the positive direction 4 units. And where do you end up? You end up at negative 5. So it's another way to do this, but it's a pretty cumbersome way day to day. You wouldn't want to have to use the number line every time you go through a collection like this. But it's kind of a neat way to look at it and to sort of check what you're doing here if you haven't done this kind of thing before. 5 minus 8. Well, that's 5 plus negative 8. We know that, though. So we just look at it in terms of sign difference here, understood plus, and this is clearly minus. So the signs are different. Let's subtract the digits. We take 5 from 8 to give 3, and then we attach the sign of the larger digit. It's negative, so we get negative 3 here. 3 plus negative 5. We can do it in one step. We can use this idea that we've been talking about, or we can say, gee, instead of having the parenthesis here, I'd rather see it in a cleaner fashion. And when a plus sign precedes a parenthesis, we can drop the plus sign and drop the parenthesis. This is just 3 minus, whoops, not 3 minus 3, my bad. This is 3 minus 5. So we have unlike signs. Take 3 from 5 to give 2 and attach the sign of the larger digit, it's negative, so negative 2. A little practice goes a long way here in causing you to become comfortable with this idea. Here we have a string of items to be added, and this often happens in algebra where we're just collecting a group of terms with one another. Now, in this situation, we could approach this as 5 minus 7, get an answer, and then whatever the answer is, collect with negative 4, and then whatever that answer is, collect with 6, and then whatever answer that is, and so on. Or we could think of arranging the problem a little bit differently and make things very easy for ourselves. We know that when the signs are the same, we're going to add digits, and it's pretty easy to add digits. It's easier to add than it is to subtract. So we'll think of the problem like this. Let's think of all of the digits that have a plus sign before them. So we have positive 5, we have plus 6, we have plus 2. So let's add those first. All right, so we have 5 and 6, 11. 11 and 2, that's 13. Now, all the ones that have minus signs in front of them, we'll collect those. All right, now I say minus signs. We could say they're all negative. We could say this is plus negative 7, this is plus negative 4, this is plus negative 3. If we want to say it like that, they're all negative numbers. We could say it like that, whatever. But because they all have the same sign, we're going to add those digits. 7 and 4 is 11, and 3 is 14. So we'll put down 14 and attach the common sign. So what we really have here is 13 minus 14. Now, 13 minus 14. Signs are different. Subtract those digits. 13 from 14, that's just 1. Attach the sign of the larger. The larger of between 13 and 14 is 14. The sign before the 14 is minus or negative. So negative 1 or minus 1 for the answer. Here we have a situation involving another string of numbers, and to me the parentheses represent some confusion here, that I would rather see the string of numbers written in that form. So I would probably go through and rewrite like this. Subtracting means adding the opposite. So instead of minus negative 2, this is plus 2, you see, or simply plus 2. When you see a minus sign preceding a parenthesis, you can just change the sign of the item inside the parenthesis. It's just a fast way to deal with the situation. Minus sign precedes the parenthesis, change the sign. Plus sign precedes the parenthesis, leave it alone, you see, and just bring it down. So here we would bring down the minus 3, and then the plus sign precedes the parenthesis, drop that plus sign, we have minus 4, and then minus 5. All right, now using the technique that we used above, just considering positive and negative numbers separate from one another, we have only one positive number, or number preceded with a plus sign, that's 2. And now we're going to collect with that. Let's see, all these have negatives with them, so we'll add the digits. 4 and 3, 7. 7 and 4, 11. 11 and 5, 16. So this is 16 with a minus sign before it because we're attaching the common sign. Then 2 minus 16, take 2 from 16, we get 14, and we attach the sign of the 16 or minus, negative 14 or minus 14. Now in a section that's coming up later, we're going to talk about interpreting words in a mathematical form. And because we're talking about adding and subtracting here, now I haven't really talked about words associated with adding and subtracting. Usually the word sum is used to describe addition. The sum of a couple of numbers means the answer when we add them. The difference of a couple of numbers means the answer when we subtract them. So we can use those words, or we will be using those words, and translating word phrases into a mathematical form. And I'd like to introduce you to that right here. The sum of 5 and negative 7. Now, sum is the answer in an addition problem. And when it says the sum of, and two items will follow, and those two are to be added together. Now, so we're taking 5 and we're adding negative 7. Now, we're adding negative 7. And you can write it like this, or you can write it like this. But at any rate, we have different signs, and so we take the 5 from the 7 to give 2, and then we attach the sign of the larger one that's negative. So negative 2 when we collect or find the sum of 5 and negative 7. Now, the difference between, now the word difference refers to subtraction. And when you have a subtraction problem, it's very important to write down the correct number first and the correct number second. And when we talk about the word difference, the difference between, let's say, A and B. Now, the word and is in there, but the word and doesn't refer to addition. It just refers to the other item in the subtraction process. And when we say the word difference, the first item that follows that word is the item you write down first. And then you put a subtraction sign and you put the other item down. So when you say the difference between A and B, it's A minus B. So here, the difference between negative 4 and 5 means negative 4 minus 5. You see, and now we see that, and just this is kind of a blind idea when you're not trying to interpret anything here or perform any operations. You're just interpreting this sentence and writing down what you understand. And then you go into thinking about how to accomplish this. So let's see, signs are the same, 4 and 5, 9, attach that common sign. And by the way, difference between negative 4 and 5, if you were thinking on a number line, how far away is negative 4 from 5? You see, it's 9 units, isn't it? And that's part of this idea. It's one interpretation here of what we're talking about. Okay, anyway, subtract negative 3 from 8. Now, just another way to indicate a subtraction problem. Here's a subtraction problem. Here's another way to indicate it. Now, subtract this from that. It's saying we're going to take this away from something we apparently already have. So subtract this number from the 8 that we apparently already have. We write down what we already have, and we're going to take away the negative 3. You see, now, I want you to notice here that the negative 3 and 8 appear in a certain order here, but they appear in a different order here. Sometimes it's thought that when writing down numbers and operations from a sentence that they are going to appear in pretty much the same order that they do in the sentence, and they really don't. It's a matter of interpretation and correct interpretation that allows you to put them in the correct order. And order is very important when you're talking about subtraction. At any rate, subtract this from that means 8 minus this. And now let's see. Subtract means add the opposite, or when we have a minus sign preceding a parenthesis, just change the sign of this number. So this is 8 plus 3, or 11 for the answer. The rules for multiplying and dividing integers are even easier than the rules for collecting integers. Here are those rules. Multiplying or dividing sign numbers, if the signs are alike, we get a positive answer. If the signs are not alike, we get a negative answer. And that truly is all there is to it. Now, to give you an idea of why this is the case, look at this pattern. Here, we know that 4 times 3 is 12. We know that 4 times 2 is 8. We know that 4 times 1 is 4. We know that 4 times 0 is 0. Now, look at the pattern that's established here. I have a multiplier here. This 4 is fixed, and this multiplier is being reduced by 1 each time. So 3, 2, 1, 0. What's the next item in the pattern? Well, it would go into the negative numbers. It would become negative 1 and then negative 2. Now, what's the pattern over here for this product? The product is the answer in a multiplication problem. 12, 8, 4, 0. Notice that the product is being reduced by 4 each time. So if we continue this pattern, then the result here should be negative 4 and then negative 8. And it turns out that that is the case, that when we multiply and we have a difference in sign, if the signs are different, we get a negative answer. Signs are different, negative answer. Now look at what happens if I take a couple of numbers. Now notice negative 4 times 3. I'm going to go through the same pattern, but we have a negative number times a positive number. The signs are different, so we get a negative result. It's 4 times 3, 12, and then negative times positive is negative. Now, okay, with that idea, we're keeping the negative 4 the same, and we're reducing this multiplier by 1 each time. And continuing the pattern, we go into the negatives down here as we did before. Notice the products, though. Here we get negative 12, here negative 8, here negative 4, here 0. Negative 12, negative 8, negative 4, 0. Gee, these numbers are increasing by 4 each time. And if we continue with the pattern, then here we would get 4 and then 8 and so on. So it turns out that when we multiply two negative numbers, we get a positive result. Two negative numbers, positive result. So if we're multiplying two positives, we get a positive result. If we're multiplying two negatives, we get a negative result. Excuse me, we get a I'm getting confused. If we multiply and the signs are the same, we get a positive result. Either two positives or two negatives, we get a positive result. When the signs are different, we get a negative result. And it doesn't make any difference the size of the numbers, the relative size. You know, that made a big difference when we were collecting sign numbers. We attached the sign of the larger digit. Well, it doesn't make any difference here. The idea is only a recognition of whether or not we have same signs or different signs. Now, by the way, the numbers that are being multiplied are called factors. These are the factors being multiplied to get this product. Right, kind of an important word to realize. The word factor implies numbers being used in this multiplication process. All right, here 4 times 3, we know this to be 12. Negative 4 times 3, we have different signs, so it's negative 12. 4 times negative 3, different signs, negative 12. Doesn't make any difference whether that 1 minus sign is associated with the larger digit or the small one. It just doesn't make any difference. Different signs, negative answers. Negative 4 times negative 3, same signs, positive answer. 4 times 3, 12. It's kind of handy here in performing these operations, I think, to think about the multiplication of digits as a separate event from the consideration of the sign. Just multiply the numbers and then put that down, and then look at the sign pattern and put down the correct sign for the answer. So it's multiply numbers and then consider the sign of that answer as separate events. Kind of keeps it separated in your head, and you make fewer mistakes like that. Here we have a string of factors to be multiplied, and notice that there are 4 factors and all 4 of them are negative. Now, in a circumstance like this, we might follow that idea that I was just talking about, that we'll think about multiplying the digits, and then we'll think about the sign of that answer, of that product. So let's find the digit or digits involved in this product. We have 1 times 2 times 3 times 4. 1 times 2 is 2. 2 times 3 is 6. 6 times 4, 24. So 24. Now, is it positive or is it negative? Well, there are several ways to figure this out. One way is like this. Suppose we pair these two together. And just think about the signs now. We're multiplying and we have 2 negatives, so that result would be positive. And we multiply these two and they're both negative, so the result would be positive. And then positive times positive would be positive. So the answer is positive or plus or simply 24. Now, notice that in associating these two factors and those two factors, I'm just pairing the factors that are negative. And it turns out that if there are an even number of negative factors, we get a positive result. If there were an odd number of negative factors, we would get a negative result. Now let me show you that. Suppose here, instead of having, I could change any one of these to illustrate what I'm going to illustrate. It doesn't make any difference which one. But if I just erase this minus sign, you see, and make this understood positive 4, then in this pairing routine, I can pair these two negatives with one another and get positive, but this minus times plus would be minus, and then plus times minus would be minus. So if we have an odd number of negative factors, we get a negative result. If we have an even number, we get a positive result. Here's another interesting situation, 5 times negative 7 times 35 times 0. Now, we could begin this by saying 5 times negative 7 and find that product and then multiply that times 35 and then multiply that times 0. But when we see a string of factors like this and 0 is one of those factors, the answer is 0. Because 0 times anything is going to be 0. And if 0 is just one of the factors, regardless of what the others look like, that answer is going to end up to be 0. Now, in these problems, you'll notice that I'm using parentheses to indicate multiplication. And actually, multiplication can be indicated in a lot of different ways. One way is to use a little dot in between the numbers. If we were multiplying 4 times 5, for example, we could indicate the multiplication like this. A lot of times when signs are involved, when a negative sign particularly is involved, it's helpful to use parentheses to kind of separate that sign and associate it with the digit that it's next to. So sometimes parenthesis is used, sometimes the dot. The little x's can be used like from arithmetic, but we kind of get away from using the x in algebra because x is a letter, and letters sometimes stand for numbers. So to avoid that confusion, we kind of get away from that indicator. Now, if parenthesis means multiply, you might recall that we used parenthesis when we showed some problems in collecting. Like a little while ago, we were talking about problems, such as this. Now, the notion that parenthesis means multiply is not inconsistent with this. In fact, parenthesis generally means two things. It means do me first, do this first, do what's in the parenthesis first. And we'll see that situation later. And then it means to multiply. Well, the multiplication here implies that we multiply times the number that is either to the left or to the right of the parenthesis, or perhaps both. But here, if we're thinking of it as multiply, we only have a minus sign to the left of the parenthesis. How do we multiply times a minus sign? Well, it's negative understood 1. That's how we resolve that situation. And negative 1 times negative 5, that would be plus 5. So this is 4 plus 5, or 9, as we knew from earlier. And we said that when a minus sign precedes a parenthesis, we change the sign inside. Well, this is why we can do that, because it's negative 1 times whatever's in there. It's just going to change the sign, you see. So all things are kind of consistent here, and everything is right with the world. Let's consider division. Division can be indicated with a division sign like this, 15 divided by 5, but another way to indicate division is by using a fraction. Fractions imply divisions, and here this is 15 divided by 5. Now, we know that 15 divided by 5 is 3. 3 is our answer here, and the emphasis that I'm trying to make here is the sign idea. When the signs are the same, we get positive results or positive answers. And incidentally, the answer in a division problem is called a quotient. A quotient. Okay, so the quotient here is 3. Now, let's figure this quotient. 12 divided by negative 4. Now, think about the digits separate from the sign. So we think 12 divided by 4 is 3. Now, what is the sign that is associated with the 3? Well, the signs of numerator and denominator are different, so this becomes negative 3. And here we have negative 18 divided by negative 6. 18 divided by 6 would be 3. The signs are the same, so it's a positive 3. And we have an indicated, understood 3 here. Now, 1 as a divisor is rather interesting. It's like 1 into 5. How many times does 1 go into 5? Well, gee, it goes 5 times. You see, when 1 is in a denominator and we're looking for that quotient, then it turns out to be the numerator like this. Now, 0 presents an interesting situation, and it's very important that we understand the difference in the result when we have 0 in a numerator versus 0 in a denominator.
Let's look at the difference between 0 over 3 as a fraction and 3 over 0. Now, we know that a fraction implies a division problem. In this one, it means 0 divided by 3. So as a long division problem, it's 3 into 0. Now what's the nature of long division? It means that we're looking for a number that we call the quotient, which when multiplied times the divisor gives the dividend. In other words, what number times 3 is equal to 0? And we can answer that question with a number, and that number is 0. Now that's why 0 over 3 is equal to 0. But look at 3 over 0. That means 3 divided by 0, or 0 into 3. Again, we're looking for a number which when multiplied times the divisor gives the dividend. In other words, what number times 0 is equal to 3? Well, no number times 0 will be equal to 3. And that's why 3 over 0 is undefined. And any time we have a fraction with a 0 denominator, the situation is undefined.